and welcome to my 24th of December and last episode in this series. There might be a bonus episode coming up soon, I'm not sure yet. But today we are going to continue where we left off yesterday. Actually, there will be no breadboard today. We are going to take a look at some of the weaknesses and some other designs for interfacing the 6502 that is out there. And I will also present in the end a product that's more likely will be something that I will build in the future. So let's get going today. And the question we have to ask ourselves is, did we actually design a working MOS 6502 computer yesterday when we did the concept sketch for this? And I am actually a bit in doubt. And this is the sketch that we drew up yesterday. And mostly I do think this will work, and maybe it will work. But I do have some concern. And one of these concerns is actually the fan out. If you can see here on the address bus, they say that the standard 6510 from back in 6502 from back in the day could drive one standard TTL load. And we are actually loading this with old school electronics. We do have the address bus connected to a EEPROM, 2 EEPROMs and 1 memory chip as default. And we might also connect some I/O chips or something also at the end, and that could prove to be a problem. So of course we can put this like so, that we just use a buffer, as we know from the theory from before, because the address bus is only one direction. So that could be a solution, and that will solve this problem. We can use a buffer chip with 3-state also if we want to disconnect the address bus. And that you have to do in the C64 and other systems where you actually have other devices or DMA that can control the address bus. But on our system and most one CPU systems without DMA, you don't have more than one device that controls the address bus, and that is the CPU. The data bus won't prove a problem, because even though this is bidirectional and stuff, it's also 3-state. And the same with the devices that we connect to the bus. All the devices have the chip enable, that is a 3-state bus that disconnects the device from the bus when it's not used. And as of now, we only have 2 devices on the data bus, as the chip select chip is of course not on the data bus, only on the address bus. And I do also have some concern about the Phi2 clock and the read and write cycle to memory, because I've seen onto some schematics now and they do some trickery there. And they also have the data bus enable signal that should be held low if you don't use it, and that we have not taken into consideration. So there are some concerns with this, and if we actually look into some designs, this 1541 is a very simple 6502 computer. Really, it's a total computer. You have 2 RAM chips, 1 RAM chip, and you do have the chip select decoding is the things that's going on down here. But this here is what I'm talking about when it comes to read-write of memory. Because here there are some trickery where the read-write and the Phi2 clock are synchronized into a NAND gate, so that we are making sure that one of these states only occurs when the Phi2 clock has a high state, it seems. So when both this clock, you can see this is inverted, so that the write is the one that is going to be low and high, and the Phi2 clock is high. So when both the read-write signal is active and the Phi2 clock is active, you get a signal here that will select the read-write on the memory. So that is of concern. we might have to include this trickery down here. And they also have about the same design on the VIC-20, but the chip select on the VIC-20, yeah, they actually used some rather complicated stuff here. And this is from the original PET. And the original PET actually has buffers on the address bus. You can see that here. Some places they use double inverters because they need the inverse address lines to something. You can grossly say that they have put buffers on all the address lines. And they also tie them high and use chips with ordinary logic. It's a 7404. So this is probably to make them more immune to noise. And you also here on this one have some trickery with the read-write signal and the phase 2 clock. But here you can see an old acquaintance of ours to do the selecting of the chips, the chip selects. This is the 7454 device that we used earlier. So this is the 4 to 16 decoder that we used in our experiment on the breadboard earlier. So here this is used as a chip select device, and you can see that they take the A12 to A15 into this counter to make the ROM and IO space probably decode. I have not gone into detail how this is decoded. It's of course possible to do when you can act from the truth table and see what the other signals go to. One other thing with the PET design is they actually made a similar reset circuit to the C64 one, and they are using a timer chip, the good old 555 timer, to make the reset stay low for as long as possible. And that is also some change that we can do with our reset line. If we take our reset line and connect it like so, that we already have determined that this is going to be ground plus 5 volt and reset, reset. And when you tie this into a double, you have this is 74 LS 14, and you take it into one more to not invert the signal, like so. This is reset low, and we also have, if we want, the reset not inverted here, if we ever need that. And this trickery here will make this more sturdy of a circuit, because as we remember, this has a curve like so, and this V low state here is somewhat undefined, so it can vary a bit. But with this, it will be a more predetermined state. But there actually are some other people that has made quite good designs for a 6502, and this is one designed by a guy called Copper Dragon, and he has used the C version of the 6502, and that is actually the chip from the Western Design Center that is still in production today. And yeah, it does have some features. It has more opcodes, and it also has the possibility to run with 0 clock, so it saves the previous state. And here they have made a really simple circuit. They have some serial mumbo jumbo down here for TX and RX, probably to input data or something. They do have a reset circuit that is very similar to ours. They actually have a reset button here that shorts out this capacitor without a resistor. I think I would have done this to make sure that this capacitor don't get, and the switch don't get fired up. And they also have made a very simple chip select here to do this. And they don't have any mumbo jumbo, as I said, about the Phi2 clock and read-write signal on this bus. They don't seem to care at all about the read-write state of this as they only use the chip enable and output select of these chips. Maybe that's okay, I'm not totally sure. But then again, this is something that he have coupled up on this breadboard and actually made to work, so he is probably right. But this might be something that is only working with the 65C02 chip. But this is the most simple design I ever seen, and he is also running the clock from a single CAN oscillator as we do in our test design. And there is also another guy that has made a minimal chip count 65. There is probably lots, but this is a guy called Grant Sale that did this in 2009 to 2013. And he has made here a serial interface to be able to connect this up to other stuff and to be able to both load and interact with the computer. But here you have this CPU, you have some chip select lines over here, and he has also done something you see here for the read-write signal. It goes into this chip here for read, and it goes to the write enable, and it also goes to the output enable, so when you are putting this low, this chip won't be connected, but this will be able to read. So this is also a very simplific design, and I think it's all its simplicity, it's rather genius. But he has done some mumbo jumbo with the clocks here, as you can see, and that's probably because of the UART and some timing issues. Because you don't need all this clock to make things work. Yeah, and he has also done just the hardware reset without no power on reset. You can see here, this has no capacitor here to actually make the chip go reset when it's starting up. So this is not into the design of the 6502. In the 6502 design, it is specially mentioned that you should keep this low for 2 to 5 clock cycles to make the CPU be able to fetch the addresses up on the address space and to make everything ready to do that fetching. So all in all, there is rather a lot to it, but I do think that our design will work with some small tweaks. But to make a computer, you really need some I/O. You need to be able to interact with the computer, and you need probably to have a display, and you need to have a keyboard at least. And the 6522 VIA is actually key to doing both of these, because this is a general purpose 2x8-bit I/O port, and this is directly compatible with the other MOS chips in this series, and this is also the chip used in the 1541 and also the VIC-20 as I/O chips. As you know, in the C64 it was swapped with the 6526 chip instead. But this is the little brother, and this is still being produced today as the 65C22 by Western Design Center. It also has 2 timers, and it can actually provide rudimentary sound also via PWM, frequency sweeps, and some frequency modulation. So this is actually quite the versatile chip, and 2 of these you could design both a general port, you can design a keyboard, and you can also have time multiplexed 7-segment or 16-segment display. This is a block diagram of the 6522 from the original datasheet, and as you can see, it connects to the data bus, and it has the control registers that connects directly to the chip. You have the clock, you have the chip select and inverse chip select, and you have some other control signals, and you have the outputs over here. And this chip can also generate IRQs and act as a serial shift register, so it can do serial communication as well. This is all from the data sheet of the 6522 that is readily available on the internet. But the more important question was, are we going to build this? And probably not. Because what I really want to build a clone of is this Emma 2. And this is the trainer that we used back in school when I was 16 years old. We used this. And then I actually used the Commodore 64 for several years. So we actually used the Commodore 64 to do the coding and assembler language. And we made a serial port and parallel port connections here to transfer the data to this trainer. But this is a readily made system. The ROM dumps are somewhat available, at least as assembly files and hex files. And all these chips that is here are more or less still available. It also uses some Motorola chip 6821, I think, for the keyboard down here. But for this I/O here, it uses the 6522. And it has RAM, and it also has this expansion port over here that you can use to connect displays and EEPROM programmers and a lot of other stuff. If I'm going to build something that's going to last, maybe this is more of a contender than actually making my own 6502. This at least will do some nostalgic programming on this one. So that was everything I was going to show you today. Yeah, sorry for there being no Christmas decoration. This is actually the day before Christmas in Norway. In Norway, it's Christmas from 1700 on the 24th. And this is actually the 23rd when I'm recording this. And I hope you enjoyed the series. There might be a bonus episode coming along later on. I'm not sure about that. I have covered most of the topics I have set out to do. I did discover some weaknesses. We have not discussed the shift register. And shift registers is actually quite vital in data communications. So that we have omitted. And we also have some other things. We have not gone into depth in simplifying circuits, making Boolean algebra and stuff. But that was not what this series was about. It was to get you interested in the Lego for real tough guys, the TTL kind of logic. And 5 volt ought to be enough for everyone. You don't need to go above 5 volt to have fun. So, Merry Christmas to everyone. Hope you enjoyed the series. Hope some of you at least stayed with me to the end. And for those who did, there might be a present coming along. If you reach out to me to the comment section, I might give away a complete C64 system to one that writes some interesting comments or feedback, and this will be randomly drawn to people who reach out, either direct to me or to the comments below. So that will be my Christmas present. Back to you.